The perfect circular flow economy. Beverage cans turn into beverage cans. Cars into cars. And window frames into window frames. The dream of every environmental engineer. At Hydro Aluminum Recycling in Dormagen, this vision is almost a reality. Every year, 36,000 tons of old aluminum window frames end up here. And it's not just old building renovation that adds to the growing mountain of aluminum waste. The lightweight metal is increasingly used in the automobile and electronics industries, for example, eventually making its way to the scrapyard. The problem is, aluminum is made up of hundreds of different alloys. And these alloys could never be cleanly separated from each other until now. When scrap aluminum was melted down for recycling, large amounts of primary aluminum had to be added in order to create the right mixture for various aggregates. The correct alloy for window frames and related products, for example. But the production of primary aluminum from the raw material bauxite is extremely energy intensive. So if new window frames can be made from old ones without additional primary aluminum, that would not only save a considerable amount of material, but large amounts of energy as well. This is exactly the challenge faced by engineers in Dormagen, who have created a new recycling facility. Their goal is to not only separate plastics and other metals from the old aluminum frames, but also from aluminum alloys containing heavy metals that are unsuitable for the production of window frames. In the first part of the process, shears and a conventional shredder cut up the frames. Magnetic separators and eddy current separators then extract the metal screws and hinges, as well as rubber, wood, and plastic from the material flow. The resulting shredder waste is almost entirely made up of aluminum, but it also contains scraps of aluminum that do not belong in the window frame alloy, such as old aluminum window handles and rivets. Sorting out these unsuitable materials is the job of a special X-ray machine. Conventional shredder waste does not provide us with efficient sorting quotas for our X-ray machine. The innovative aspect of our second shredder phase is that we reshred and sift the material, giving it an optimal preparation for our X-ray transmission machine. Unlike the first shredder, the second one does not pound the scrap metal with hammers. Special blades cut the coarse aluminum parts into chips measuring some 4 to 6 centimeters. Aluminum is an extremely abrasive material that wears out other metals, so the blades are made of specially hardened steel. The two shear shredders are able to produce more than 100 tons of aluminum chips per day. The subsequent screening unit filters out the smaller parts. The result is a material flow with nearly homogeneous geometry. This makes the detection of individual fragments possible in the X-ray machine that follows. But unsuitable alloys containing high levels of copper or zinc can still be found on this conveyor belt. A special sorting unit separates these fragments. Two powerful X-ray sources with the energy of 160 kiloelectron volts examine the individual parts. To protect the workers from high levels of radiation, the unit is covered with a heavy lead sheathing. The aluminum chips evenly cover a more than 2-meter wide conveyor belt. It carries the chips at a speed of 4 meters per second. The X-ray lamps examine them from above. The X-ray detector under the belt measures the incoming radiation. The more unsuitable heavy metals, such as copper and brass, that are found in the aluminum scraps, the less radiation comes through. That way, a computer can distinguish between the various alloys. Based on this data, the computer operates a strip supplied with nearly 400 pressurized air jets, which blow off the unsuitable material. That way, 1,000 parts per second can be analyzed and sorted accordingly. The technology is supported by the German Environment Ministry's Environmental Innovation Program. Support was previously provided to Hydro's predecessor, WMR Recycling, a typical mid-sized German company. The government program aims to support smaller firms that want to protect the environment with innovative technology. The unsuitable heavy metal alloys make up between 2 and 4% and are fed into other material cycles. Most of the recycled material is the aluminum alloy 6060, and for decades this alloy has been used for the production of window frames. Thanks to the innovative shredder and sorting technology, 30,000 tons of this highly valuable material can be recycled each year, and it's easily loaded and transported to the customer. Customers like the Hydro Aluminum Company in Rackwitz near Leipzig. Hydro produces some 90,000 tons of aluminum billets each year. They're an important primary material for pressing plants which use the billets to produce aluminum profiles, including profiles for the window-making industry. This unique and high-quality sorting technology in Dormagen allows us to drastically minimize our primary metal use. The alloy composition they provide corresponds to the alloy composition we deliver to the pressing plants that produce the corresponding window profiles. It's absolute top quality. The recycling material is melted down at the plant in Rackwitz. With the help of a special procedure, aluminum billets measuring some 25 centimeters are produced under a casting table. The billets are lowered into a hopper. After a cooling phase, the so-called extrusion billets are ready-made from the recycled aluminum, and almost without the addition of primary aluminum. If you look at the entire production process, even this relatively small-scale project provided a large CO2 reduction of more than 200,000 tons a year. The German Environment Ministry considers this a key technology for the metal industry on its way toward more environmental protection and resource conservation. Pressing plants then process the billets into profiles with various cross-sections, which are once again turned into window frames and end their life back on the scrap pile. The circle closes without the addition of further raw materials, saving large amounts of material and energy. But the Dormagen engineers are also working to further refine the process. In the future, they want to do more than sort out the heavy metal-laden alloys. They also want to separate the alloys that are free of heavy metals. then the perfect circle closes, not just with window frames, but also with cans and even cars.